Hey guys, today's lesson is 8.1.10. It's in GeoGebra, so make sure that you've clicked the link. The other thing I want you to make sure you do is log into GeoGebra with your Google account. There are specific directions on how to do that in the top of this page where I posted this video, so just make sure you check that out. If you log in with your Google account, then you will be able to revisit your work later, which will be helpful just in case you want to do like half of this assignment and then come back to it. And then you'll be able to log in for all future GeoGebra accounts. So the first activity asks you to reflect triangle ABC over line AB and then label the image of C as C prime. So just wherever C ends up, label it as C prime. Go ahead and pause the video and answer this question here. Okay, so I want to review with you how you do this reflection. This doesn't have the reflection tool. It's just asking you to draw. It does have the reflection tool. So we can create a line of a reflection. We want to draw the line segment first, and we know we're going to reflect at the midpoint over line B. And then we can click on the reflect about a line tool, select the triangle we're reflecting, and select on the line, and it'll reflect the triangle for us. So notice that when we reflect over a side of the triangle, the reflection is connected. And this is what your reflection should look like as well. We're just reflecting over line AB. And in the second question, it wants you to rotate triangle ABC prime. So that's the new triangle that you created. They put it for you here, and we also just did it here, around angle C so that C prime matches up with B. So we're rotating ABC around, I think I said around C, but we're rotating ABC prime around A so that C prime will match up with B. So you don't even have the rotation here, but what's important to notice is that if you were to rotate triangle ABC prime around A so that C matched up with B, your new triangle would simply end up back on top of ABC. And so that's why they didn't provide you with any reflection tools, or I should say rotation tools, because the rotation ends up back on the original triangle. So what can you say about the measures of angles B and C? Go ahead and pause the video and answer this question here. So you should have noticed that angle C and angle B are identical. And the reason why we know that to be true is because when we rotated or reflected the triangle, it was always the exact same as the original copy, regardless of where the angle ended up. So for example, when we reflected ABC over the line segment AB, we ended up with triangle ABC prime, which is just a copy of ABC. And when we slid it back over, C prime ends up on top of B prime and those angles match up. So we know that angle B is equal to angle C. They have the same exact angle measure. All right, the next activity says here is triangle ABC. Draw a midpoint M on the side of AC. So why don't we do that first before I send you off to do this? We want to draw a midpoint M on the side of AC. And if you want, you can label it M, the text button. At a midpoint M. And your directions are to rotate ABC 180 degrees using the center M to form triangle CDA. Draw and label the triangle. So remember, you can use the rotate around a point feature. You select the object to rotate and the center point, and then you enter the angle of rotation. So pause the video and try this rotation. Okay, so your rotation should look something like this. You want to click on the rotation tool. You want to click on the triangle you're rotating. Click on the rotation tool. Click on the triangle that you're rotating. And we're rotating around point M. It's being a little finicky for me. We're rotating around point M. Let's see if I can get this to work. I might have messed up. Okay, so I just clicked on a point on accident instead of clicking on a point to rotate. So it looks like the problem is that I drew the point and I didn't need to draw the point. But it's being a little bit finicky, so let's see. Ooh, we have a midpoint tool. See, some of these GeoGebra tools definitely get tricky. It's our best option for online learning, but stick with me. I'm not going to pause the video. So I'm going to refresh and I'm going to try one more time. Select the object to rotate, and for some reason it's making me put a point down. Maybe we need to put the point first. Let's try one more time. Select the object to rotate. I'm going to make a midpoint of AC and then select the point of rotation. And it is not working for me on the rotation tool. But here's what's important to know is if you're rotating this entire triangle ABC, which maybe we would have had to draw it on our own. For some reason, it's not working in the GeoGebra video, which is okay. That's why you're watching the video. If you were to rotate triangle ABC around a midpoint, and we had it drawn here all nice, midpoint M, I should say, your triangle would end up spinning around in this direction so that it ended up right about here. And my sketch is not going to be that pretty, which is why we should be using the tools, but the tools are giving me trouble. It would end up right here. And we end up creating a new shape with the rotation of triangle ABC. And again, that's just the spin of triangle ABC. What is the new shape? What kind of quadrilateral is it? Now, it's a little bit hard to tell because the drawing isn't perfect, and I don't have line tools here either. But imagine that this is a perfectly straight line, and you just reformulated the triangle. What shape does this create? So ideally, if our rotation had happened correctly, this would create a parallelogram. And we know that because the opposite sides are equal in length and they're also parallel. So we know that quadrilateral ABC is a parallelogram. So it tells you this in the next task. In the activity, we made a parallelogram by taking a triangle and its image under a 180-degree rotation about the midpoint of the side. This picture helps you justify a well-known formula for the area of a triangle. What is the formula and how does the figure help justify it? So what's the formula for the area of a triangle? Go ahead and type that in your box. You can pause me, type that in your box. So the formula for the area of a triangle is 1/2 base times height. And if we were writing that out, it would look like this: 1/2 times base times height. Notice that a triangle is half of a parallelogram. It looks like I lose my H when I scroll. The triangle is half of a parallelogram. And the formula for a parallelogram is just base times height. So we just proved why the formula for a triangle is 1/2 of base times height, because it is half, literally, it takes two triangles to create a parallelogram. And that is why the formula is true. All right, so the next task says, the picture shows three triangles. Triangle 2 and triangle 3 are images of triangle 1 under rigid transformations. And there are some questions for you below. Describe a rigid transformation that takes triangle 1 to triangle 2, and what points in triangle 2 correspond to A, B, and C. And describe a rigid transformation that takes triangle 1 to triangle 3. What points in triangle 3 corresponds to points A, B, and C? So go ahead and give this question a try. It's asking you, how can we transform 1 to 2, and how can we transform 1 to 3? So there are multiple correct answers. You should have paused the video and given this a try. A common answer is that for both triangles, we can reflect around the midpoints. So we can reflect triangle 1 around the midpoint of AC, 180 degrees to get to triangle ACD. And we can reflect triangle 1 180 degrees around the midpoint of AB to get triangle ABE. And you would just want to tell me which angles correspond to which. So if I took triangle ABC, and you can imagine that I spun triangle ABC in this direction, until it ended up on top of A, B, E. For example, point C would correspond with point E because it ends up right on top of point E. So it's asking you to tell me the corresponding points in both of these questions. There are multiple correct answers, but again, if you were stuck, rotation around the midpoint is one great example. So go ahead and pause, get caught up with me, and unpause. So the next questions ask you to justify two segments that are the same length. And in the next question, two angles that are the same measure. And I'm not going to give any answers for this one, but what I reminded the students of in class is that when we complete a rigid transformation, the side lengths stay the same and the angle measures stay the same. I'm going to repeat that one more time. Under a rigid transformation, the side lengths stay the same and the angle measures stay the same. And so that should help you to look at these translations or transformations rather and see side lengths that are identical and angle measures that are identical. So I want you to answer these two questions, and then the last few tasks that deal with triangle MON. So I'm scrolling just to show you, but it's from here downward, triangle 1, ONE. I'd like you to complete independently. That's how we did it in class. When you're done with GeoGebra and you're finished through this video, make sure that you go back to Schoology because there's a few other items that are on your to-do list for today.